Hello everyone, welcome back. In this video, we'll talk about the concept of density, beginning with understanding mass and volume. Mass is the measurement of how much matter or stuff an object has. The base unit for mass is the gram, but we also commonly can use kilograms, milligrams, and other prefixes. To measure mass, we commonly use a scale. Nowadays, we use electronic scales that conveniently display the mass when you place an object on top of it. Volume is the measurement of how much space an object occupies. Measuring volume has a couple methods, all depending on what kind of object you measure. Measuring a three-dimensional geometric object should be the most familiar to you. For instance, the volume of a perfect cube is the length times the width times the height. The volume of a perfect sphere is 4/3 times pi times the radius cubed. Notice that I use the word perfect. To use these convenient formulas, the shape of your object must be perfect. Notice that no matter what, we always end up with multiplying measurement of length, such as meters, 3 times. Your volume measurement must always be cubed or to the power of 3. Back to our object. What if you must measure the volume of an irregular object, like my favorite model Ferrari car? A cool Greek guy named Archimedes figured out how to do this a long time ago. To measure the volume of an irregular object, like my model car, we can use a method called water displacement. In this method, we submerge the object into a container of volume, causing the water to rise. By subtracting our original volume from the final volume, we can get the volume of just the object. This is because the object submerged in water displaces an amount of water equal to its own volume. This ties in super well to measuring the volume of liquids. To measure the volume of liquids, like the water in the water displacement example, we use graduated cylinders, or labeled cylinders. However, what you'll often notice is that liquids, especially water, curve at the surface. This curvature is called a meniscus, and is due to a property that we'll discuss in a later unit. To accurately measure the volume with a meniscus present, we read the measurement at the bottom of the curve. However, it's extremely important you read the meniscus from its level. Don't look from up top or from the bottom. Your eye must be on the same level as the curve. With these concepts concluded, let's move on to density. Density is defined as the ratio of the mass of an object to its volume. You can imagine density as how much stuff is in an object at a given volume. A good example of density would be to compare a pillow and a block of iron of the same volume. It's safe to say that the block of iron would be significantly heavier. But why? They have the same volume, right? It's because the block of iron has a lot more stuff in it than the pillow, so it ends up being heavier. The idea of the ratio is a great way to understand how to calculate density. Density can be calculated by dividing the mass of an object by its volume. Try to calculate the density of my TI-84 calculator, which has a mass of 200 grams and a volume of 300 cubic centimeters. Your density should be 0.7 grams per cubic centimeter. Notice I conserved significant figures, rounding my decimal to one significant figure. You can also solve for mass or volume, given the two other values. An important concept is that density is a property special to the material or object. No matter how big or small my iron block is, the density remains the same, as long as it's not mixed or combined with anything else. Practice these concepts using the worksheets and the description below. In the next video of Unit 1, we'll discuss the concepts of precision, accuracy, and percent error. See you guys in the next one.